Your HDFS is a virtual layer on top of local file system. Here in the virtual layer, in the virtual layer, in this HDFS, this also data will store in the form of blocks only. But here the block size is a little bigger. The block size is 64 MB or 120 MB based on the Hadoop version we are using. If we are using Hadoop 1 version, the block size is 64 MB. If we are using Hadoop 1 version, the block size will be 64 MB. If we are using Hadoop 2 version, the block size will be 128 MB. And the replication factor is 3. And why it has to be 3, why it can't be 2, why it can't be 4, or why it can't be 5, that details we will discuss. And why only 3, why they come up with the 3, why can't it be 4, or why can't it be 2. So but it doesn't mean that we cannot change. These are all default configurations. We can go ahead and change. Where to change, how to change, I'll be showing you, because we are going to do Hadoop setup with our own hands, right? It's like we will be doing, like, it's not like someone just give you a software, just dump it, and you're just not going to do. So what we are going to do, we are going to install the software, then we are going to configure all the details. We are going to configure all the details. So here in the HDFS, as soon as you install Hadoop software, and as soon as you start the Hadoop services, it will form a layer on top of local file system. That layer is called HDFS layer. So from your terminal, I can say from your terminal, if you're trying to access HDFS file system, it will go and store, if you're trying to access the HDFS layer, or if you're trying to store any data into this layer, your block size will be 64 MB. But it means that you will be having your local file system as well as you will be having your HDFS. It means as soon as you install Hadoop software in your system, and as soon as you started the Hadoop services, in your machine start supporting two different kind of file systems. One is your normal file system, whatever the file system you are using. One is that normal file system, and other one is HDFS file system. So when you are talking to HDFS file system by using a special kind of commands, or to access this HDFS file system, we have a different kind of commands or different kind of way to access this. And when you are accessing your normal local file system in the normal way, that you can access this local file system. Right, let's try to understand more detail about the what is the HDFS. Okay, so HDFS architecture HDFS architecture to form HDFS architecture to form HDFS architecture or to to form HDFS layer, we need two type of nodes. What is a node? Node is a physical machine which is connected in the network. Node is a physical machine which is connected in the network. Let's assume that I have a 4 machines in the network. Let's say node 1, node 2, node 3, and it will be connected. So what it means, they are connected through network. It means it's kind of which is it's like a one central point, or we can say which is a node which is connecting two different edges. That's called node. A physical machine, the node in this terminology here, the node is a physical machine which is connected in the network. So we need to form a HDFS layer, to create a HDFS architecture. We need two type of machines. We need two type of machines. So one is master type machine. One is master type machine. Master node, we'll call master node. And other one is slave type of machine. Other one is slave nodes. Okay, so let's see as architecture wise. you will be having a master type node. That master type node we will call name node. We will call name node. Why we have to call as a name node? Why can't we give a different name for this? We will talk about that as well. Okay, we will see that in detail. And so we will be having slave type of machines. We will be having slave type of machines. We will be having slave type of machines. These slave type of machines we will call data node. Data node. These two machines will be connected each other. These two type of machines are connected each other, and they will be communicating through network using RPC protocol. Remote procedure call. Remote procedure call. And they will be connected each other, and your slave machines will be talking to name node, will be talking to a name node every 3 seconds. Every 3 seconds. Every 3 seconds. We can configure this value as well. This value also configurable value. This value also configurable value. Every 3 seconds. 1 second, guys. I think if you guys are asking me to send the meeting link. So every 3 seconds, this data node will be talking to name node. It's like it is informing to name node saying that I am present, I am alive, I am connected with you, like that. So if your name node didn't receive 3 consecutive heartbeats, we will call heartbeats. We'll call heartbeats. If your name node didn't get the 3 consecutive heartbeats from the data node, your name node treat it. It is in out of network. It will treat that it is in out of network. So all the machines will be reporting to name node. So if you see this kind of architecture, so what we use, it looks like our day-to-day life master slave architecture, no, manager and team members. One manager and a team members. It's the same architecture, right? There will be one team manager and we'll be having so many team members, right? It's exactly representing the same, right? So when it comes to master slave architecture, in our team, who will be working on the defect fixing or development work? Only team members. Even manager will not assign himself a development work or the bug fixing or testing work or whatever the work, because he is meant for, or he is made for, to manage the team. He will be having a different activities to do. But so here also the same, your name node will not store any data. It will not store any actual data. What are the data we are going to process, what are the data we are going to store, that data will not be stored into name node. That data will not be stored into name node. Your data nodes will store the actual data. Which workhorse is here? Data nodes. So these guys are storing the data. That's why we are calling data nodes. We're calling data nodes. This is also exactly looks like your distributed file system, no? As we discussed yesterday. It also looks exactly similar like a distributed file system, right? So this is also distributed file system, but it is Hadoop distributed file system. These are all Hadoop distributed file system, right? So these machines will be keep reporting to a name node every 3 seconds, and these machines also internally connected each other. Now then, how it is different from normal distributed file system? How it is different from normal distributed file system, which is network file system? So let's see that difference. Here here the data will store across all the machines, all the machines. It means your data will not go and store in a single machine. The data will go and store across all the machines, and the data here, while storing the data also, this file system is capable enough to read bigger blocks, seek bigger blocks, like you can seek 64 MB or 128 MB block at a time. And it has a functionality, or it has a built-in feature. When you start storing any data, it will store into 3 different places and 3 different machines. It will store the data into 3 different machines for the backup purpose. So these values are configurable. We can change those values. Okay. So here, let's see how the data will store into the 3 different machines. Here we will not be having a dedicated machine. The data, let's say when I want to store employee data will not store in a single machine. The employee data will be across multiple machines. How it will store? Let's have a look. So as I said, these machines, data nodes meant for storing the data. Name node is meant for managing these guys, managing these data nodes, and this your name node will maintain the metadata about the data. What are the data we're going to load into HDFS. That data information, the data details, where and all the data is stored, will be stored by your name node. Like if we take a simple example, suppose if we got a new work, how our manager will distribute the work, how will we keep track of the work, and how will we keep reporting to him status. The same way these guys also will be sending the status, like we have connected, I'm in office today, I'm doing this. So they'll be informing it. So let's look at, so now I'm going to store some data in this, and let's see how it will work. Let's say I have some data which is belong to Flipkart, or which is belong to Amazon, whatever the data is. This file size is 1 GB. This file size is 1 GB, and my block size is 64 MB. Let's take my block size is 64 MB. So this 1 GB data, so it will divide into 64 MB blocks. It means it will come close to 16 plus, it means 17 blocks will come. First, you want to keep the data into HDFS, and you will execute. What you will do, you will execute some command in the one machine. That machine will call a client machine. Wherever you are executing your command, whichever the machine you are executing the command, that machine will call as a client or edge node. Okay, so we'll talk more about the client and edge node, how they will work. We'll talk more about them. So let's try to understand here. So as soon as you execute your command to put the data into HDFS, so this is client machine. This client machine first will check whether this path is available or not. This file has to be there, some source. So we are copying the data from the source to HDFS now. We're copying the data from source to HDFS. So first it will check the data is available or not, and the file is available. Then it will break into pieces, depends on the block size. Depends on the block size. How my client knows about my block size? Because your client machine also will have a Hadoop software. Your client machine also will have Hadoop software, and your client machine also will be having a default configurations. And what are the configuration you change, the change should be applicable in all the machines. Suppose if you change any one of the machine, the change should be available in all the machines. Now your client will divide this file into blocks. Your client will take the first block. Your client will take the first block, and he will go to the master, a name node, saying that I have a piece of work which has to be done by three members. Which has to done by three members. Let's assume that there is a new client came and talked to your manager, saying that I have a piece of work, and the piece of work has to done by three people. So I need three people. Your client cannot come directly and talk to you, no, because a client never knows who are all the team and who are all working on what topic or what task. Your client cannot come directly and talk to you guys, because your client will not be having any clue. So what are the employees, and where and which task they are working. So only your manager knows about it. Only your manager knows. Your client will not be knowing it. So your client will go and talk to the name your master, your manager, and ask for three resources to finish the work. Why three resources? Because my replication factor is 3. And he will go and talk to the manager, and manager will identify the people based on their availability, who is working on what and who has the time, free time, and they will assign based on the expertise and based on the work type and all. He will assign. So same way here also, name node will identify who are all free, and your name node identifies. And see, actually there is something called block placement policy. We'll talk about that. Block placement policy. And there is something called rack awareness. Based on these two algorithms, it will identify the machines, which machines has to be select for the client. For time being, let's assume that it is selecting the who is nearest to the client. For timing, just understand, he is selecting the some machines who is nearest to the client. So now as soon as the request goes to the client in the form of RPC call, your name node, actually what he will do, client, so client will tell the file name. Let's say this is a flip Amazon, and in your request you will tell, no, you will take from the source and you want to write into destination. You will tell that I want to write into the destination. Your destination path you will give, right? You will give the destination path, right? So your name node, what he will do, and he will check some validations. The first validation is whoever executing this command is authorized to write or not. And second is the destination is already exist or not. If it is already exist, it will throw IO exception saying that you cannot write because the file is already exist. And the second one, if the user who is executing this command, he is not have a permissions, write permissions, so then it will says that the user does not have a permissions to write. That validation will be done, and it will make an entry. Then it will make an entry. It will start create a file. Just create a file path. Then it will identify the machines who are all free. Then your name node will reply with the IP addresses of those machines. IP addresses of those machines. The IP addresses it will give in the form of sorting order. IP addresses will give in the form of sorting order. How it will give? What base it will sort? It will sort based on the network distance from a client to a data node. So let's assume that client is there in one rack and data nodes are in the same. So it will most of the time it will identify who is near to the client, I'll show you the real-time architecture, so then you will understand what is the rack and how it will work. And your name node will identify the machines and will sort based on the client or network distance from the client, and it will assign to the client. So client will connect to the first machine. Client will connect to the first machine. This is the machine 1. This is machine 3. Machine 5. So as soon as the request came, right, your metadata information will be making a note of here. So your name node will be maintaining this information. That's called metadata information. So what is that metadata information? Amazon file came for specific location and they come up with a block 1. They come up with a block 1. Block 1. Now this guy's client is connected to machine 1 and he will create a data pipeline, guys. Along with this IP address, he will create a data pipeline. It's called data output stream, and he will create it, and after creating it, he will tell that you machine 1 you need to connect to the machine 3. Machine 3 will tell that machine 3 you need to connect to the machine 5. So what he will do, he will start passing the packets. Actually this 64 MB is a bigger file, right? We cannot send through a network. So the 64 MB file will be divided into small packets. Small packets. The first packet, as soon as it's come to machine 1.
Bira?
Yeah, go ahead.
One doubt.
Yeah.
See, the block comes to data node 1, okay? And how data node 1 knows that I have to copy it to data node 3, and data node 3 knows I have to copy it to data node 5, because they don't have this metadata information, right?
Very good question. Here, as soon as your client create the data pipeline, right? He will create a data pipeline with the IP addresses. In this, it is like an object call. Okay, what he will do, he is calling a write method on your output stream. So that write method, he will be passing the what are the IP addresses he has to connect. So as soon as the request come to the machine 1, and he will be having IP address which needs to connect to the machine 2, and he will be having IP addresses to which machine he has to connect. That way it will connect. Okay. Is your doubt clear, because?
Yeah, and one more thing. Suppose the client will pass the block. So it will send the blocks and 3 IP address in the block information. It will send one block, and with the data stream it has got 3 IP address. Okay.
Correct.
Suppose it will come to data node 1, and meantime data node 1 is down.
No, that I will tell you because that will take the failure case. Okay. First we'll try to understand the success case, then I'll take you to the failure cases.
Okay.
Yeah. Anyone has any other doubt, guys? Okay. So the packet 1, as soon as it's come to machine 1, the machine 1 will pass to a machine 3, and machine 3 will pass to a machine 5. Then your machine 5 will give the acknowledgement saying that I have received successfully. And machine 1, actually it will come to here, right? It will come to here. Machine 1, machine 3. Machine 3 will give acknowledgement to machine 1, and machine 1 will give acknowledgement to machine client saying successfully your packet is received acknowledgements. So it will say the acknowledgement packet. It's not complete block as of now, it's just received only packet acknowledgement. So it will start pushing all the packets to these machines. So these machines will, let's assume that we take the only success case as of now, so we'll talk about the failure case later. Now the block is successfully stored into machine 1, machine 3, machine 5. Successfully it is stored, and the same will be repeated to block 2 as well. The same, again the client will go and pick block 2, again he will go with the again will go and talk to the name node, again he will go and talk to the name node asking for different machines. It doesn't mean that all the file will store on 135. So the data will be distributed across the multiple machines. If you observe here, it is my Amazon file. The Amazon file is not stored in a single machine. The whole data, let's say 17 blocks are there. The 17 blocks are stored in the, if you have a big cluster, it may store in 17 different machines, or it may store in 5 machines, 10 machines based on the availability it's available. right? So block 2 will may go to block 2 information may go to machine 2, machine 4, machine 5, and block 3 may go to machine 1, machine 2, machine 3. Block 4 may go to, and so on. It means the data is distributed across the multiple machines, across the multiple machines. Now, as soon as they receive the block, no, as soon as they receive the block, as soon as they store the block successfully, they will inform to a name node. The name node will make entry in this. This is called metadata. This is called metadata. This metadata will be available in two different files in name node. Those files are called edit file and fs image. Those files called edits and fs image. Edit is like a log file, and fs image will be having this file system information file. We'll talk about that fs image and edit log. So as the concept comes. Okay, this is a successful story. So successfully the data is stored in HDFS. And now if you observe if you compare with the normal distributed file system, in the normal distributed file system, the whole data resides in a single machine. If this machine goes down, I have a problem. But here the data is across the multiple machines. The data has been chunked into pieces, and each piece has been loaded into different machines. Even though one of the machine goes down, still I do have a recovery, I do have a backup to get the data. Any doubts, guys, still here? Any doubts still here?
Yeah, yeah, Vira. Actually the data node will give acknowledgement to each other, also to name node, right? So that name node can change the metadata information.
Yes. So they will send the acknowledgement to name node once they completely store the whole block.
Okay. Okay.
Data node will talk to the client when they send the acknowledgement. When to send the acknowledgement only, the data node will talk to the client. Any other questions, guys?
Yeah, Veera, Sudhir here.
Yeah, tell me, Sudhir.
Yeah. So like you were telling like once a client will get information about like an IP address of the node data node.
Mm.
So he will go and he will write and then he will get back acknowledgement.
Mm.
So like name node first time he just gave a idea like these are the IP address, it's free, you go ahead and you can write the data. But next time because next time how name node will know like availability about the data, because we are sending only acknowledgement, we are not sending like let's suppose like a data node 5. In data node 5 first time they wrote and just they gave acknowledgement. So we are not knowing like we have filled all the data, like let's suppose like a 128 MB. So maybe in the last let's suppose like a B70 and you told like Amazon is having 1 GB. So in last maybe it's having only 50 MB.
Correct.
So 50 MB data got loaded into a data node 17. Let's assume 17. So on that time,
data node 7. Okay, data node 17.
Yeah,
okay.
Data node 70. So on that time, 128 minus 50. So rest of that MB is free for this to get used again.
Okay.
So we are sending only we are not sending like this much space is available. Go ahead and you can write next time also like something.
Okay. So here,
for
yeah, go ahead, Sudhir. Sorry to stop you. Go ahead.
yeah, it's done.
Okay.
Like, how to know?
Yeah. So here, as soon as we talk about the block, so 128 MB is the block, right? This is the what we're talking about, a block. So it doesn't mean that we are reserving 128 MB of the space for a block. We're not reserving. If any data is coming with 128 MB or more than that, that data we are dividing into two parts. Like if suppose any data came greater than 128 MB, what we will do, first 128 MB will put into one block, well treating as a one block, and the rest of the, let's say 128 130 is my block size, my file. 130 is my file. Now this 130 will be, first 128 will go into one block, next 2 MB will go to second block, right? This 2 MB is not going to reserve 128 MB space. Your 2 MB is not going to reserve or occupy 128 MB of the space. It will take only 2 MB of the space. it will take only 2 MB of the space, not the 128 MB. So here the block is smaller block for your 2 MB. Here the block is bigger for 128 MB. The rest of the space, it can be used for other blocks, it can be used for other files, it can be used for any other purpose.
So this information node will have this?
Yes, the name node will be having this information.
Okay, so next time like they can inform to client like this much space is available for this particular node, so you can go ahead and you can write.
Yes, all the space information will be available with your name node. So not only this remaining, see here 120 MB, no, rest 126, not only 126. So what is the hard disk capacity of this? Is it a 1 TB hard disk? Let's assume that.
Okay.
It will be having 120 it will be telling, your name node will be knowing that this has this much capacity of it, capacity of the data node.
Okay, yeah, thank you.
Nice doubt, guys. So any other doubts? Any other doubts, guys? Please go ahead and ask. Okay, it seems that everyone is good. Guys, you guys have been muted, so if you want to talk, you guys need to click on the mic symbol, which is showing in a red color in our case. Click on that, it will become a green, then we'll talk. Unmute and talk. Okay, if you guys have any doubt, please. Okay, good. So this, it will be having a metadata information in the name node. So tomorrow if I want to read this data, or tomorrow I want to process this data, I will go, when I want to read, I have to give where my data is located. No, I should know this destination path, right? If I want to read the data, I should know where my data is there in HDFS, right? I want to process this data, I should know where the data is loaded, right? So when I give a request for the read, or when I give a request for the process, you directly go and talk to the name node. You cannot talk to the data nodes. So I would like to tell you here, the data nodes, when you can see, if you know the IP address of the data nodes, you may able to connect, but you will not be having access to connect. Let's assume that you have access, you connected. When you connected to these data nodes, you never realize this block is belong to Amazon, this block is belong to eBay, or this block is belong to some XY file. You will never know it. It will just load the data in the form of blocks. So let me show you in the real time. Let me show you in the how the data will store. Let me show you here. So as soon as you install Hadoop software, you need to configure something called data directories for the name node and data node. I'll be showing you that. In the data node, the data will go into store into data node, and your data node also will maintain something called block pool. This BP means block pool. The which data has to go into which block pool. We'll talk about all this information very detailedly. If you see, this is the data, and okay, first let me show you from the UI. So if I show from the UI, you'll get some idea. This is my data, guys. This is my data which I loaded in this. Here, this is the data, the stock data, something, some bigger file, small file, command. This is my data. Okay, this is my data which I stored in HDFS. So this data I cannot see here. That data, whatever data I load in HDFS, I cannot see in your normal file system. I cannot see here. I cannot see here. So I can see only desktop and all those things, which is I can see in the local file system. From your normal UI, you can see only your data, what are installed, what are the softwares you have installed. That kind of data only you can view. So let's say if you have some of your own data, that type of data only you can view, right? So that kind of things only you can view. But you cannot view whatever the data I have loaded. See here I have something called training one. So you cannot see the training one in here. You cannot see. It will not be visible because that is there. Your training one is there where? Your training one is where? In this layer. The training one is there in this layer. If I want to see that data, I should go with a Hadoop view. I should go with a Hadoop view. I cannot see this, whatever the data I loaded into HDFS, I cannot see it from here. But I can execute some commands and I can see. I can execute some commands and I can see. Look at here. The commands are like Hadoop fs -ls slash. I can see like this. I can only see like this. See here, I have something called training 1. So I can see from the command window, but I cannot see here. That won't be possible. We cannot see here. But to see that, we have something called UI. We have something called UI. This is like here it is running in the local host means because my Hadoop is running in my current machine. That's why I have kept it as a local host. Okay, so that's why I'm able to see from here. And you have some other tools as well. There is something called Hue and there is something called Ambari. Okay, these are all Cloudera Manager. These are all the tools for the different distributions, and when you can go ahead and look at from that tools, so that I will show you how we can see in that tools here. So I'm seeing these are the data it is. So let's assume that I'm seeing the data which is 128 block.txt. Okay, the same data as I said, it will be stored into the data node. Okay, in the data node here it will store. Can anyone tell me and show me where is the 128 which directory it will be? Let's take any data. It's actually loading. So these are the blocks. These are the blocks. You go ahead and tell me which block is belong to that 128 MB file, whichever the file I'm showing. No, this is my file name 128 MB block.txt. This is my file. So can we anyone recognize this file is there in these blocks? We cannot recognize because the data is chunked into pieces. The pieces has to load it into some different machines. So as I shown in the diagram, this Amazon data has been chunked into pieces. The pieces loaded into different machines. So even though if you logged into that machine, you will see a piece. You will see a piece. How I'm seeing here a block, the piece of data. I'm seeing some piece of data here, but I never and ever cannot understand this pieces belong to whom. I never understand the species belong to whom. Understand guys? So here you have some pieces of data. This species belong to that data. This species belong to other data. I never understand that. So first of all, you will not be having access to connect to a data node itself. If you are able to connect the data node, let's assume that you have some rights and you found the IP address and all. Even though you connected to the machine, you can see these kind of chunks only, but you never realize that that data is belong to what. You never understand it. You never and ever understand this block is belong to that. So that information, this block is belong to whom? That information will be there with whom? With whom? Your name node. Because your master is maintaining that information. Your master is maintaining that information. Block 1, okay, which is their mission 1, that is block 1, that's belong to file 1. This is file. So your blocks will be like this guys. They will be having unique ID for each block, unique number for each block, and the respective metadata of that block. Metadata of the block, I'll tell you what this is called. CRC, cyclic redundancy check file, which is called like a checksum file. We will talk about that. Okay, so this file will make sure that whether the block is corrupted or not. So I will detail explain what is that, how it will work and all. Any doubts guys? Any doubts? So here when the data is loaded like this, and the process also will go in the same way. So the data, if I want to process Amazon data, I will go and tell that I want to process your Amazon. I'll tell to my manager with that my name node. Actually, it's called something called job tracker. We will talk about those daemons later. Job tracker daemon. There is something called job tracker daemon. There will be something called task tracker daemon. We have a separate session for the processing. We are just seeing the storage. So this as soon as you submit a job, it will go and talk to this job tracker. The job tracker will talk to name node, and name node will refer the IP address and which block where it's belong to. That mission that will be given back to here, and these blocks will be processed wherever the data is loaded. These blocks are getting processed. Let's say block 1 I want to process. It will process any of the machine, any one of the machine here. It will process any one of the machine here, and block 2 will process some other machine, unique blocks, and block 3 will be process some other machine. Now, what does it mean? The data is getting processed parallelly. The data is distributed across the multiple machines, and the data has the by default it's called automatic replication. While loading the data itself, it's putting into 3 different machines, and the processing also happening the parallelly, and it has, while processing any one of the machine goes down, your job is smart enough, you don't need to worry about it. I will launch the same job in other machine, same task in other machine. You have automatic fault tolerant is there, and also wherever the data is loaded, I'm processing there only. Wherever the data is there, I'm processing there only. I'm not moving the data. I'm not moving the data. Moving data is more costly operation. Moving data from one hard disk to another hard disk is a very costly operation. Okay, so let's look how the real time the data looks. So I'll be explaining this presentation because I'm having already all the slides, because I don't want to not display the slides. If I start displaying the slide, people will start reading the slides. So first I want to explain the things, then I want to show the slides. So that way it will give more information. So that's why I'm not displaying the slides in the first shot. First I'll explain the thing. I'll explain the whole thing, what is this, what is that, and later I'll go and show the slide. Now if you read the slide, you will get the clear idea. That's the reason. Okay, so big data, we had a discussion about this, what is the big data and how the big data, and so we have already seen this. And the data changes. In the 80s it was a kilobytes, and so now it is in data in the petabytes and petabytes. So the data has grown very fastly, and the different kind of data also is coming. Okay, so this is the different classification of the data. We have seen like a CS structured data, semi-structured data, and unstructured data. Different types of the data we have seen, and there is something called characteristics of the data. These are the characteristics of it. Characteristics like I have shown you only 5 here, but it is actually total 6. There are actually 6. So we have explained what is the volume, what is the velocity, variety, no, veracity, variability is missing here. The variability I have explained yesterday in the last class. So volume, the data volume is increasing exponentially. What is how much of data you are processing? That data will say, so it's the volume of the data. You can talk about here like a social media data, or you can talk about exchange, New York Stock Exchange, sensors, Twitter, Facebook, any sources where the data is getting generated, YouTube, right? So 5 zettabytes of data exist in the digital universe today. It's more than that. As already 6 increasing. This slide I have prepared 2 years before. So, and amount of the data from the different sources you can look at here, and the Facebook and all those. These are the some random numbers. Okay. Okay. So YouTube users are uploading 48 hours fresh videos, hourly basis videos in every minute of a day. Every minute they're uploading 40 hour videos. Okay. So you can look at velocity. The data is generated very fast, and the data also needs to process very fast, like online data analytics, your sensor monitoring, right? The streaming, we need to get the data and we need to process it. And the different sources of the data, where we are getting the data and the different sources. You have a sensors, you have a satellites, you have no, medical, you can say healthcare devices. Ideally the healthcare devices are like sensors, right? You have so many different ways of different sources who are generating the data. And you can see variety of the data. So different kinds of the data, different types of the data, we just discussed various formats of the data. And veracity, how good the data is, how trustworthy the data is, right? Is it accurate or inaccurate? We need to identify the quality of the data, we need to check. And value, this value is the most important thing, because whatever the data you have processed, that should give you some value to your business, right? So that's represented by value. I'll share this slide to each and every one, so not to worry about the much. So next, what is the importance of the big data? So we can see the business market, security, law enforcement, and improve healthcare, sports, predictions, human decisions. So there are so many use cases are there for each and every analytics for the big data. So what are the big data we are processing? This kind of use cases we'll be doing. The banking sector are using, telecom sector using, right? So healthcare. So everyone has started using the big data analytics. What is the big data? At the end of the day, the big data provides you a big opportunity for the big analysis. So we will be doing a big analytics, and when your big analytics will give you a big results and which will provide you a big opportunities in the market, right? For the business I'm talking about, and what we get a benefit. So what if we are a big data developers and we can learn big and we can earn the big. So we can lead an advanced quality of the life, and we can overcome the limitations of the traditional approach. So this is the traditional approach. How the traditional approach we to work, we will be having a different kind of sources from where the data is coming. The data will be go through ETL process, and the data, what are the data we are going through ETL process, that will be normalized and stored into data warehouse system where the traditional data will be located. From the data warehouse system, we'll be having a different processor. It's not showing in this diagram, and the data will be processed, and we will get the reports. Those reports used by your business users and business analysts and administrators. So then they'll start taking the decision based on the report, a campaign, whatever they want, promotions and campaigns, based on their values, based on the reports there, they will go ahead and improve their business. They'll take the business decisions. And drawbacks of the traditional approach was it is expensive and it's not that much easy to scalable, right? So it is really expensive. It requires a lot of investments to implement or upgrade the existing system. It will be a problem. So why it is a problem? Because you are getting a huge amount of the data. So when you are getting a huge amount of the data, yes, it is really a problem. It's really expensive with an existing system. And the scalability or expanding your systems is a really challenging task, and the time consuming systems. We already discussed in the very first or second video of demonstration. The videos already have shared with you guys. In the individually I have shared yesterday. So I'll be creating a separate group for our this dispatch, and I'll be sharing the videos, and I'll be sharing the links over there. And difference between your SQL and Hadoop. So this is I have not yet explained. So I would like to take opportunity to explain this tomorrow, and I will explain this tomorrow, and I will show you this. Okay, this thing I will show you tomorrow. Okay, and scalability, and this also scalability also I'll explain tomorrow with an example. Okay, once I explain, then I'll take you through the slides. Then it will make you very much clear. Right. So I want to show this history. We're going to discuss very detailed history of this, and the thing which I want to show you is, yeah, this is the ecosystem. You'll be having HDFS, which is the storage layer, and you'll be having our HDFS. You'll be having HBase, and you'll be having a MapReduce for the processing layer, and you'll be having a different tools on top of it. Okay, you have something called Flume for the streaming data. You have something called Scoop for the to send from the structured data. So we will be talking more about this. This is not the only limited to your ecosystem. Your ecosystem is grown like anything. It is compatible with any tool. So we'll see more about your Hadoop ecosystem. Actually, I want to show this. Yeah, so without a distributed file system, with a distributed file system, what is the advantage? So without distributed file system, you'll be having independent machines. You need to log into independent machines, and you need to process. When you have a distributed file system, you can have only one entry, and you start accessing that. And if you want to process the same data in one machine, if you want to process in a distributed manner, the same amount of the data, the time consuming to process the data will be reduced a lot. So here you have 1 TB of data which you want to process in a single machine, like a HANA. So if anyone knows about the HANA, so that's the best example for it. So the transfer rate is 100 Mbps. Here also transfer rate is 100 Mbps. IO channel like 4 cores. Here you have a 4 core, and here each machine has a 4 core. Right? So when you process the data in one machine, to find the time data by speed, your data is in MB because the speed is in MB. So I'm converting into MBs into seconds, right? And I mean to convert into hour, sorry. So we're converting into hours, then we're finding this. And this is what this much time it's taking for to process the data. This Mbps, right, the seconds, we're converting into minutes. Actually, we are seeing here minutes. We're seeing here minutes, so we're converting into minutes. And if it is one machine, it's taking this much of time. It is a distributed manner. If it's a 10 machines, because of the parallel process, it's same thing will be get processed. For this is the difference. Okay, less amount of the time because of the parallel process, because of the distributed environment. Okay, so this is what I want to show you. This is how the Hadoop cluster will looks. You will be having a racks. You will be having a racks like this, and each rack will be having a machines like this. In these machines, you will have these white colors all called data nodes and name nodes, and you will be having one of the machine as a master and the rest of the machines are the slaves. And uh, here, your client also will be residing one of the machine. This big the black color, these things are racks, and this small things, these are called your nodes, your node. So this is how it looks. And if I mean, if you want to put in picture representation of that, it looks like this: rack 1, rack 2, rack 3, rack 4, and so on, rack n. And you'll be having machines like this. In this, all your data node will always run with a task tracker, and your name node will run with the job tracker, or job tracker can be different machine. We'll talk about that very detailedly. Why can't a task tracker cannot be a separate service? Why job tracker is a separate service? So we'll talk about the difference, because that's also one of the most important interview question. So this is how it looks in the real time. We'll be having a data nodes, and we'll be having racks, and this is I'll be explaining your rack awareness. So based on these racks, and two copies will store one rack, another copy will store another rack. Why two copies will but we have a three copies, no? So two copies will store in one rack, other copy will go into other rack for the data recovery. Even though complete rack goes down, still I have a data recovery. So that I will explain. This is what I want to show you. That's why I brought this slide here. And if you want to see, if you want to understand the protocols, what are the protocols and all, so our data node to name node is RPC protocol, client to name node is RPC protocol, data node to data node is a HTTP protocol. Okay, so this is about for today's class, guys. If you have any doubt, please ask me, and I will clarify your doubts. In the tomorrow class, we will be seeing we'll be going through some of the slides and difference between the HDFS and Hadoop, and I'll be showing you how to scalable, and I'll be showing you some of the important things of the Hadoop, which is called your metadata information. So your name node, how your name node maintaining the metadata, how your data nodes maintain the blocks. We'll be seeing that information in the coming classes. Any doubts, guys? Any doubts?
Yeah, Veera, Rangnath here.
Yeah.
Regarding job tracker and task tracker, are you going to explain in the next class, or how it is?
I'll be explaining the job tracker, task trackers in processing, when we are going to processing mode. We are in a phase of storing the data, right?
Okay.
If you have any doubt, you can go ahead and ask. I'll tell you that job tracker, task tracker thing.
No, I just wanted to know how those things work, so I just asked.
Those also follows as similar as a master slave architecture. Your job tracker will be master, task tracker will be slave. So I'll explain the details in the in the classes. Okay. And the Kader is asking, is big data visualization is different branch of study, or it's a part of the big data analytics? See, actually the data visualization comes and along see, you data visualization means you want to see the results in the form of reports in the visualization way. So that is either with us it's part of that big data only, but the tool is different. So you may go with the click view, you may go with a Tableau, or you may go with something different kind of, you may write your own application to visualize your data. Okay, can you please tell me what is the configuration is required for the laptop to install Hadoop? Very good question, guys, for all of you guys. See, anyway we are going to use Apache We're not going to use Hadoop or Cloudera at this time, at this point of time. To install Apache Hadoop, we need the Linux environment. We need a Linux environment. It doesn't mean that we cannot use Windows environment, but so we'll be doing a hands-on and everything in the Linux environment. So we need to install Ubuntu. First, we need to install Ubuntu or CentOS. If you guys already have any Linux flavor, it's okay. So Ubuntu. If anyone has a MacBook, directly we can go and install Hadoop in that MacBook, we can run it. If anyone has a Linux machines, we can directly install and we can. If anyone has a Windows, here the problem will comes. If your machine is a Windows and if it is a 4 GB RAM or lesser than that, what I recommend, go with a dual boot. If you have a lesser than 4 GB RAM, go with a dual boot. Dual boot means you will be having Windows and Ubuntu, both Linux, both will be there. So at the time of using Ubuntu, you have to select Ubuntu. At the time of you're using Windows, it means when you go with the dual boot. So when you're using Windows, the 4 GB will be allocated for this. When you're using Ubuntu, the 4 GB will be allocated. So your memory will be utilized properly. When you have a greater than 4 GB, we can go with the VirtualBox like this. We can go with the VirtualBox like this. The VirtualBox is a software where you can download. It's also open source. You no need to pay to anyone. You can download a VirtualBox. You can select. You can create one machine. You can create one machine. So create one machine is like it's kind of a virtual your resources from your laptop. Few resources you are giving to other machine. Like a RAM is some portion of the RAM you are giving to other machine. Some portion of the hard disk you are giving to other machine. So some portion of the processor you are giving to other machine. So you will start using that. So whatever I have done. See here, I'm using Windows as well as I'm using Linux here. Sorry, I'm using Linux here. This is VirtualBox. If I'm using dual boot, either I can use Windows or only either Windows or Linux I can use. So that is the dual boot and this is this. So this is how we'll do. So once you install Ubuntu, then we can go ahead and install our thing like uh, Hadoop and other softwares. Understand, Kranti?
Yes.
Yeah. Any other doubts, guys?
Bira, these installations you will teach, right?
Yeah,
All
I'll
these things.
teach. Yes, I'll teach and I'll share the documents and we'll do in the classroom itself.
Okay.
So everyone, before going for installation topic, everyone please ready with your Ubuntu installation. Either if you have a, I hope everyone has, nowadays everyone has a greater than 4 GB only. Even 4 GB is there, we can go with VirtualBox. The problem is your system will be little slow. So if anyone has a less than 4 GB, get it done the dual boot. Get it done the dual boot. Okay. So we can go and use up that machine. So if everyone has a more than 4 GB, we will go and install the VirtualBox and we will install Hadoop in it. I mean, we will install Linux in it and we will install Hadoop on top of it. So we can do that hands-on in the classroom itself. Okay.
Yeah, Veera.
Yes.
So having more than like a 4 GB, 16 GB RAM.
Mm-hmm.
So you are going to help us to install VirtualBox as well as Hadoop, right?
Yes, VirtualBox, Linux and Hadoop softwares.
Thank you.
Yeah. Guys, I'm missing some of the contacts from here. So I need all your contacts.